So the goal is to find how many islands, square islands in a matrix that consist entirely of ones. Let's look at this. So we have this like matrix, and we want to count squares. Imagine this matrix 0, 1. So the strategy is to reuse the previous result. We go row by row, like this, and we count the length of this current one's island. So at this time we have one, then second one, and the interesting stuff starts on the second row. This one is just single island. It's one. Then we go next, and we have second one. And if we at this time we can already detect some possible island with the size of 2, but this 0 prevent us to make it, so we have to check it. Just look at this diagonal 0, and also we have to check this one up to the current. So we see this is 0, and we look at what was the answer at this time. It was 0. And what was the answer at this time? It was 1. And what was the answer at this time? It was also 1. So we choose a minimum of 0, 1, 1. And this 0, we do it not just 0, it's 0 plus 1, of course, because if this would be 1, this size would be 2. So we have to do plus 1. So go next and look at this. This is where the first interesting part starts. We count the current row is 3, and we look up, and we see this already is 1, and we look left. Left is just our current counter is 3, and we look diagonal, and we see this is 1, so we can use it. We check up, and we check diagonal, and we see that we can make this square size of 2. So let's consider some case where we have square size of 3, like this. How that would be? So we count like usual way. Count this like 0, 1, 2, 3. 1. And this is 2, and diagonal is 0, so we can't use it. So this is just a single cell. We remember this cell as 1, because it's as just a single one. Then we go next. This is 3. And we see the diagonal has 1, and we can use it. So that we also check up. It's also 1. So our current size of possible square island is 2. So we write this as 2. Then we go next, and we count as 4 to the left. This is like 1. We wrote this as 1 because we remembering our size of the island. So this is the blue is just a counter, and the 1 is what we remember. This is like 1, and this is 1, and that makes us possible to count this as 2. So this is became like messy. let's make it another way. So 1 1 1. Little bit this. So this is when we writing remembering the current size is just 1. This is just also 1, also 1, and this is 2 because this entire square has size of 2. And when we go on here, we see this as this is, by the way, also 2 because it has this size. And we look at the current length is 3 to the left, and we check up and diagonal. Diagonal has 2. We're doing 2 plus 1 to make it reuse this size of 2 square with up to this diagonal. And we check with this 3 to make sure that all the row have a length at least of this size. And also we checking how much we can take to the up. So we checking this 2 plus 1 to check that this can be used as also. So all the values up have ones. So this make us have all three values are like 3, also 3, and this also 3. So we can write this as 3. So that's basically it. And when we counting, when we considering the new value and it has 3, what we are appending to the result, we appending this 3. So this basically means that we appending this, then this, and then this. So this is a 3 separate squares, and matches with our length. So there's all squares that have the same corner value. That's how you can reason about it. The implementation is pretty much trivial if you count this corner case. So you should check left and left diagonal, and you should check up also, because that's how it works. And you should compare the minimum of 3 values: left, diagonal, and up. So, and then you I use the same array, but you can use a separate DP array, and we appending this to the result. And we also saving this to the DP array to check the next row, column. So that's it. Let's look at my previous year solution. So this time I used several custom test case to check myself. I checked pure diagonal like this, and also check this like, so I don't make sure I didn't overcount. So it's from 2024. Basically, I used the same logic. It's minimum of 3 values. So as a solution, I just code golf. Okay, that's it.